Okay, good day guys. Now we are going to start with another chapter of derivatives which is called as composite function. Some authors even refer to this as chain rule. Now what is done in this is you have the same formulas that you had in rules of differentiation. The only difference is, I'll show you what the difference is. Here you have to differentiate twice. For example, if it is d by dx of x raised to n, it is nx raised to n minus 1. But instead of here, the important thing to note is that these two terms are same. But instead of d by dx of x raised to n, if you have u raised to n, if this term and this term is not the same, if these two terms are not the same, that is when you have to use composite function, right? Do we understand when composite function has to be used? When the two terms here, when you are differentiating with a number and the number that you are differentiating are not the same, if the two variables are not the same, you have to use composite function. How do I write composite function formula? Composite function formulas are same as the normal formulas, except that this is going to be nu n minus 1, except that at the end you differentiate the given variable again. So at the end you will have d by dx of u. So this is also called as composite function and chain rule. Guys, I'll illustrate this with the help of another formula. Suppose if I had d by dx of sin x. D by dx of sin x is cos x. But instead of that, if I had d by dx of sin u, here look at this term and this term is same, both the variables are same. What if the two variables are not the same? It is when the two variables are not the same that you use composite function. So this is going to be cos u, the formula still remains the same, at the end of which you apply d by dx of u. That is composite function, right? So in composite function, basically the two variables are not the same. When the two variables are not the same, that is when you have to use composite function. Fine, do we get this in clear? Let's see a couple of sums, guys. Y is equal to x square minus 3x plus 4 raised to 5 by 2. Okay. Now, if I have to differentiate this, differentiate with respect to x, you will get d by dx of y is d by dx of x square minus 3x plus 4 the whole raised to 5 by 2. Ideally, I should have used the formula d by dx of x raised to n. But look at this, I have only x here and I have a polynomial here. Whenever you have a polynomial, you will use u raised to n. So in this case, if I use the composite formula, this is, I'll just write the composite formula here. I'm going to be using d by dx of u raised to n is nu n minus 1 d by dx of u. Right? Why am I using composite formula? I'm using composite formula because here you have only x and here you have a polynomial. So if I use this formula, this is going to be n u, this whole term is going to be u, x square minus 3x plus 4 raised to n minus 1 d by dx of u, x square minus 3x plus 4. So this is going to be 5 upon 2 x square minus 3x plus 4. This is 5 minus 2, 3 upon 2. Now solve this. D by dx of x square is 2x, d by dx of 3x is 3, constant is 0, so that's your answer. Fine, do we get this in clear? Next, let's try another sum out. Suppose if I have y is equal to square root of sin x minus cos x, right? Again, differentiate with respect to x. So you will get d by dx of y is d by dx of square root of sin x minus cos x. Again, here I could use a composite function. We have a formula d by dx of root x. D by dx of root x is 1 upon 2 root x. But here, since these two terms are not the same, I will use the formula d by dx of root u. The two terms are not the same. Here I have a polynomial, here I have only x. D by dx of root u is 1 upon 2 root u. The formula remains as it is. at the end of which you will multiply d by dx of u, right? So in which case you will get d by dx of y is 1 upon 2 root sin x minus cos x d by dx of sin x minus cos x. So this is going to be 1 upon 2 root of sin x minus cos x. D by dx of sin x is cos x, d by dx of cos x is minus sin x. So that will be your answer. That will be your answer, right? Next, let's see another sum, guys. Y is equal to tan 2x degrees and minus sin 3x degrees. Now if you remember your limits, I had informed you that whenever you have the angle in degrees, you have to convert it into radians. All formulas are applicable only when the angle is in radians. Now how do I convert this into radians? The first thing I'm going to do is convert this into radians. To convert this into radians, I'm going to multiply by pi divided by 180. Similarly, to convert this into radians, I'm going to multiply by pi divided by 180. Right? Now, differentiate with respect to x. So you will get d by dx of y is d by dx of tan 2 pi x upon 180 minus sin 3 pi x upon 180, right? D by dx of tan u, d by dx of tan u is nothing but sec square u d by dx of u. Composite formula I am using, right? Because here instead of x you have 2 pi x by 180 minus d by dx of sin u is cos u d by dx of u, right? So this is going to be sec square 2 pi x by 180. Now 2 pi by 180 is constant, d by dx of x is 1, so this will be into 2 pi by 180 minus cos 3 pi x by 180. 3 pi by 180 is constant, therefore that comes outside the derivative. D by dx of x is 1, so I need not write this. So this is going to be pi by 180 common. So this will be 2 sec square 2 pi x by 180 minus 3 cos 3 pi x by 180. That will be your answer. Fine, do you understand this? Let's see another sum, people. Next, let's see another sum. Now, suppose if I have y is equal to sin 5x, right? Let's see how do we do this. Now sin 5x is nothing but sin x the whole raised to 5. Whether I write sin 5x or I write sin x the whole raised to 5, it is the same thing. Okay. Now differentiate with respect to x. If I differentiate with respect to x, I'll get d by dx of y is d by dx of sin x the whole raised to 5. I will use the formula u raised to n u n minus 1 d by dx of u. So this is going to be 5 sin x the whole raised to 4 d by dx of sin x is cos x. That's your answer, right? Let's move on to the next sum, guys. D by y is equal to tan 4x plus 3, right? Let's see how do we do this. Tan 4x plus 3, differentiate with respect to x. So you will get dy dx of y is dy dx of tan 4x plus 3, right? Now this can be written as dy dx of tan u, which is nothing but sec square u dy dx of u. So this is going to be sec square 4x plus 3. Now dy dx of x is 1, 4 as it is, 3 is 0. So in that case this is going to be 4 sec square 4x plus 3, right? Let's see another sum, people. Y is equal to cos square 7x plus 2, right? Now this can be written as y is equal to cos 7x plus 2 the whole square, differentiate with respect to x. So you will get dy dx of y is dy dx of cos 7x plus 2 the whole square. Here you could use the formula first, u raised to n. So that is n u n minus 1 dy dx of u, right? This is 2 cos 7x plus 2. Now here again you could use composite function. Dy dx of cos u is nothing but minus, which sign I am writing here, minus sin u dy dx of u, right? Simplify this. Now 2 sin theta cos theta by using multiple angle is nothing but sin 2 theta. Similarly here dy dx of 7x is going to be 7, constant is 0. So your answer is going to be minus sin twice 7x plus 2. Fine. Let's move on to the next sum, people. Seventh sum, y is equal to root of x square plus 1 plus 1 upon root of x square plus 1, right? Let's see how we do this. Differentiate with respect to x. So you will get dy dx of y is dy dx of root of x square plus 1 plus 1 upon root of x square plus 1, right? Now when I open the bracket, this will be dy dx of root of x square plus 1 plus dy dx. This I'm going to take it in the numerator. Root can be written as raised to 1 by 2. When I take it in the numerator, it will be minus 1 by 2. So this will be x square plus 1 raised to minus 1 by 2. dy dx composite formula. Dy dx of root u is 1 upon 2 root u dy dx of u plus dy dx of u raised to n, n u n minus 1 dy dx of u. I'm using composite formula in both the places. So you will have 1 upon 2 root of x square plus 1. Dy dx of x square is 2x plus 0 minus 1 by 2 x square plus 1 raised to minus 3 by 2. Dy dx of x square is 2x plus 0. Here I could take 1 by 2 common, 2x common, in which case I'll have 1 upon square root of x square plus 1 minus 1 upon raised to 3 by 2 is nothing but x square plus 1 into root of x square plus 1. Here 2 and 2 gets cancelled. X. I could take square root of x square plus 1 common, in which case you will get 1 minus 1 upon x square plus 1. Simplify this, x upon square root of x square plus 1. This is x square plus 1 minus 1 upon x square plus 1. Plus 1 minus 1 gets cancelled, so this is going to be x cube upon x square plus 1 square root of x square plus 1. That will be your answer. Right? Let's see another sum, people. Y is equal to cos 4x plus cot 2 minus 3x. Right? Let us see this. Differentiate with respect to x. So you will get d by dx of y is d by dx of cos 4x can be written as cos x the whole raised to 4 plus cot 2 minus 3x. Now this is going to be d by dx of cos x the whole raised to 4 plus d by dx of cot 2 minus 3x. Use the formula u raised to n. U n minus 1 d by dx of u, right, plus cot u is minus cosec square u d by dx of u. Fine. Now this can be written as 4 cos x the whole cube. D by dx of cos x is minus sin x minus cosec square 2 minus 3x. 2 is 0, 3x is 3. So your answer is going to be minus 4 sin x cos cube x minus into minus. Minus into minus will give you plus 3 cosec square 2 minus 3x. Fine, do we get this idea? Let's move on to the next sum, guys. Y is equal to x square plus 5 the whole raised to 10 x minus 2 the whole raised to 5. Let's see this. Differentiate with respect to x. So you will get d by dx of y is d by dx of x square plus 5 the whole raised to 10 x minus 2 the whole raised to 5. Now here, since there is multiplication between two terms, first you will use the multiplicative formula, that is uv. So this is v derivative of u plus u derivative of v. Right? Now this can be written as x minus 2 the whole raised to 5. Now you will use composite formula, that is d by dx of u raised to n. So d by dx of u raised to n is n u n minus 1 d by dx of u plus x square plus 5 the whole raised to 10. Again you will use the same formula, d by dx of u raised to n. N u n minus 1 d by dx of u. Now this can be written as x minus 2 the whole raised to 5 into 10 x square plus 5 the whole raised to 9. D by dx of x square is 2x, 5 is 0, so you need not write that. X square plus 5 the whole raised to 10 into 5x minus 2 the whole raised to 4. D by dx of x is 1, d by dx of 2 is 0. Let's see what can I get common here. I can get x square plus 5 the whole raised to 9 common. Similarly, I could get x minus 2 the whole raised to 4 common. Besides, I could get 5 common. If I take all these terms common, that means here 1x minus 2 remains, 5 is gone common outside, so from here 2 will remain, this is common outside, and 2x will remain. Similarly, from here x square minus 5, x square plus 5 the whole raised to 9 is gone out, so you will have x square plus 5 remaining, 5 is out, this is out, x minus 2 the whole raised to 4 is out, so this is 5 x square plus 5 the whole raised to 9, x minus 2 the whole raised to 4, this is nothing but 4x into x, 4x square minus 8x plus x square plus 5. So this is going to be 5 x square plus 5 the whole raised to 9, x minus 2 the whole raised to 4. This is 5x square minus 8x plus 5. I cannot factorize this quadratic equation, therefore the answer remains as it is. Okay, let's see the next one, guys. Y is equal to cos 2x upon root of 2x square minus 7, right? You have division here, so first you will have to use the division formula, differentiate with respect to x, d by dx of y is d by dx of cos 2x upon root of 2x square minus 7. You will use the u upon v formula, so this is v derivative of u minus u derivative of v upon v square. This is going to be square root of 2x square minus 7. D by dx of cos u is nothing but minus sin u d by dx of u minus cos 2x. D by dx of root u is 1 upon 2 root u d by dx of u upon, in the denominator you will have square and root cancelling each other, so you will get 2x square minus 7. So now this is going to be minus 2x sine minus 2x root of 2x square minus 7 sine 2x minus cos 2x upon 2 root of 2x square minus 7. D by dx of 2x square, 2 as it is, x square is 2x, so this will be 4x. D by dx of constant is 0, that means d by dx of 7 will be 0 upon 2x square minus 7. You could take this 2 and this 4 gets cancelled to give you a 2 here. Now I will take LCM here. If I take LCM here, this will become minus 2x square minus 7, because root of 2x square minus 7 into root of 2x square minus 7 will give you 2x square minus 7 sine 2x minus 2x into cos 2x upon 2x square minus 7. This common denominator will come down, so that will be root of 2x square minus 7. Here again I could take minus 2x common. So if I take minus 2x common, this is going to be 2x square minus 7 sine 2x minus plus cos 2x upon 2x square minus 7 root of 2x square minus 7. That will be your answer. This finishes your basics of composite function. This was the last sum. Chapter is done. Okay. Thank you.